I'm Micah.
I'm Nobu.
I'm Chris.
We're trying to make it across the country on a bus powered by used cooking oil. We're seeking out backyard innovators who build earth-friendly inventions that work. It's a road trip experiment where anything can happen.
New Bedford, Mass is Zegen, and what do? They take waste, like municipal waste, and then debris from construction and turn that into gas.
That's pretty much what they do. They burn it at incredibly high temperatures.
My question is, how different is it from incineration?
And I'm wondering how much waste they can actually process, like if that's actually a good solution instead of putting in waste in the landfill.
We're 50 miles south of Boston to check out a company that's turning garbage into electrical power. We want to see their furnace that's filled with liquid iron, and we want to learn the steps towards extracting viable fuel from waste.
Hi.
Good morning.
Hi.
Chris,
Megan.
Micah.
Nice to meet you.
So you guys generate power here from garbage? Is that the idea?
We are a 1,500 ton per day construction, demolition, debris, processing, recycling center. We're also a municipal solid waste transfer station. What we're looking at doing here is processing the construction, demolition, debris that comes in, making a fuel product for the Zegen facility, power up some turbines and make electricity, put it on the grid.
What does Zegen stand for?
Zegen stands for Zero Emissions Generation.
So that's the goal.
That's the goal. I mean, if you think about it, what we're doing with waste right now is not that smart. So you get a bunch of people together, and they create a lot of waste. And then you ship it off to a landfill that produces methane, which is 22 times more harmful to the environment than CO2 even. So it doesn't make sense to ship it off and just waste that energy potential.
Where do we start?
So do you want to grab some hats?
Yeah, sure.
Right,
That's the best.
The process is called waste gasification. Other companies do it, but don't always end up with high-quality fuel. Zegen wants to do it better, and it starts here, as they sift through debris for what they want in their furnace.
This is the first step in the sorting process.
This is the first step. It's our slow-speed grinder. You look up on the top there. It sizes the material so when the things go up in the picking room, the guys can actually do something with it instead of trying to pick through that material like that. It's too big up there.
You ever find anything good?
Oh, yeah. Scotty's found good stuff. They found a lot of money.
Yeah?
Oh, yeah.
How much money?
Everybody found $2,000.
$2,000?
Wow.
$2,000 on the belt.
That's pretty good, Dave.
This is our picking room where all of our recycling, most of the recycling gets done up here. The first bin here, the guys are pulling out what we call non-grindables, stuff that we don't want to get into the ground product at the end because my grinder doesn't like it.
So you're basically looking for the carbon in the wood and the carbon in the cardboard.
Yeah.
Yeah.
The carbon in the plastic.
Right.
Yeah. Anything that's a hydrocarbon will has energy in it and it will gasify.
That's got a stain on it. That's a stain.
Oh, there's a stain.
That's no good.
Okay.
Once we've separated out the combustible material, it's ready for the furnace, which will release the gases in the wood.
This is the final end use of the construction demolition debris that's come into our facility. This is the fuel. It's about 85, 90% wood, about 10% other fractions of other type of hydrocarbons.
This is essentially free, right? Other than your processing.
It's better than free because we get paid to take it. But for now, people don't know what to do with this. They have to pay to get rid of it.
Next, all this is going into a bath of molten iron, and we'll see if the furnace can convert it into a source of energy. We're in New Bedford, Massachusetts, because we want to see how Zegen is turning free construction waste into electrical energy. The first step was to separate out optimum fuel for the furnace.
This here is the beginning of the Zegen system. We're going to go ahead and bring the material in this hopper. From there it goes into a bucket elevator. It's going to go all the way up to the top of our feed system. And we can go upstairs from there and show you what we're doing up there. This whole feed system, we pull it right over on top of the furnace. It's going to go on top of that feed tube that you see that's sticking out of the furnace right now. We're actually going to lower that into the furnace. Pull the feed system over, bolt it together. We're going to start it up.
Why do you need to put the actual feedstock into the molten metal? Is that where it gasifies?
Yeah, if we laid it on top, we don't think we'd get a very good gasification. We're putting it down underneath. By the time it bubbles up to the top, everything will be gone.
The heat of Zegen's furnace is the key to extracting usable gas. The wood and cardboard is plunged into 2,800-degree iron, which causes it to separate into its elements. The hydrogen bubbles up, and the carbon dissolves in the iron. Oxygen is injected to mix with the carbon to form CO. This synthesis gas of hydrogen and CO is called syngas.
What's inside of here right here?
That's just a little bit of the slag that we pulled off the top. A little about a half-inch layer of hardened material on top of the back.
Okay.
So why don't we go ahead and get you dressed up, and we'll get one of you guys in there and start pulling it off.
The slag is a crust of impurities that won't mix with the iron, and it blocks access to the gas we want to capture. So Micah has to remove some without adding himself to the chemical reaction.
Slap it to the side. Okay.
Then Chris collects a sample so that the percentage of gases can be analyzed.
Go, don't stop. Right to the top.
So this is the carbon level?
The carbon number there, that 275, that's the one that we're concerned with. We want to maintain that about 2.5 to 3.5, maybe to 4.
High-quality syngas is collected in this tube and channeled out of the building to be stored in these tanks. After being cleaned and compressed, it can be burned to generate electricity.
It is pretty amazing that we can come up with a process that will turn what is right now a problem. We don't know what to do with it. It causes all sorts of environmental problems when it's in the landfill, and turn it into something useful again. And clean, renewable power can come out of what was once your garbage.
Zegen plans to process 450 tons of wood waste a day, producing enough syngas to provide a day's power needs for 20,000 homes.